So yeah, thank you very much for joining the presentation about the Swiss Voice project. Instead of me doing the introduction, I will just let our synthesized voices do the introduction. Oh, and I quickly have to share the screen again because I think I didn't check the box to share the sound. Okay, now it should work. All right, please tell me if the audio is not working.
Schon zusammen, habt ihr gehört. Computer können jetzt auch Schweizerdeutsch reden. Also mein Handy kann nur Hochdeutsch. Ja, aber an der TH können Computer jetzt auch Schweizerdeutsch.
Das glaube ich nicht. Und wenn, dann sicher noch Zürichdeutsch. Typisch Zürcher.
Was soll denn das jetzt heissen? Nein, ganz viele verschiedene Dialekte. Auch Berndeutsch. Kein Wunder, für Berndeutsch brauchst du sicher nicht die schnellste Maschine. Ja, den kennen wir schon. Und auch Baseldeutsch? Ja, klar. Und auch Walliserdeutsch? Erstaunlicherweise ja, und noch viel mehr. Das ist ja super.
Also das will ich sehen, eine Maschine, die bündelt.
Ich auch, zeig mal, wie das tönt. Ja, dann müsst ihr jetzt gut zuhören. Die Präsentation fängt jetzt gerade an.
All right. Let me give you an overview over what I will discuss today in my presentation. So first of all, I want to quickly talk about the Swiss style dataset, which is a dataset that we collected during this project of over 30 hours of high quality Swiss German recordings in 8 different dialects. Then I will show you some results from our speech synthesis models that we trained with our dataset. And then I also want to show you our Swiss Voice Assistant, which is a research prototype which we developed together with Recap AG. All right. So let's first talk about the Swiss style dataset. So the Swiss style dataset are recordings of high quality Swiss German audios. Which means they are specifically recorded for speech synthesis. That's why they are high quality, without any noises that you don't want to have for speech synthesis. The collected audios always have Swiss German transcripts and also high German translations, which is quite nice because with this data you can also train a small Swiss German to High German or High German to Swiss German machine translation model if you want. Here you can see the dialect distribution that we have. All of those first 6 dialects have the same amount of sentences. The difference in amount of audio just comes from the speed of the different speakers. For Zurich dialect, we have a little bit more sentences, around 4,000. And for Graubünden dialect, we even have over 10,000 sentences collected. But so far, we only released around 3,000 of them. The other batch of Graubünden sentences will be released soon in the future. More information can be found in our paper that we released together with the dataset. There you can find all the information about how exactly we recorded the audio and what the exact setup was. And you also find links to our downloads and again, all the results that we produced with the dataset. Okay, so next, let's talk about some of our results that we have. So first of all, I want to show you some single speaker speech synthesis results. They are based on the famous Topotron architecture for speech synthesis in combination with WaveNet. So let's have a listen.
Wir leben im Zeitalter vor Technik.
Wir leben im Zeitalter von der Technik. Wir leben im Zeitalter von der Technik.
Wir leben im Zeitalter von der Technik. Wir leben im Zeitalter von der Technik. Wir leben im Zeitalter von der Technik.
Wir leben im Zeitalter von der Technik.
Wir leben im Zeitalter von der Technik.
All right, so as you can hear, the quality already sounds pretty good. For some of them, you can hear small problems in the audio quality, but for some of them, it already sounds pretty human-like. And another feature that I want to highlight that we worked on with a master student was code mixing. So here, for example, we have a sentence in Bernese Swiss German with one English word, know-how. And if we just give it to our normal speech synthesis Bernese model, it sounds like that.
Viel Know-how ist während dem Krieg und der Besatzungszeit verloren gegangen.
So she says know-how, like a real Swiss person would say. But actually you say know-how. And with our code mixing model, it sounds like that.
Viel Know-how ist während dem Krieg und der Besatzungszeit verloren gegangen.
So now it's pronounced in the correct way, like know-how, not know-how. Right, so other results that I want to highlight, because we also trained a MultiSpeaker, multi-dialect model with our dataset, which is based on this paper here. And in this speaker and dialect embedding space, which is just a vector space, we can actually move around, and like this we can, for example, interpolate between different speakers, which is quite cool. So here we are interpolating from the St. Gallen speaker to the Graubünden speaker.
Das Gebäude, das ich gesehen habe, das ist sehr groß gewesen. Das Gebäude, das ich gesehen habe, das ist sehr groß gewesen. Das Gebäude, das ich gesehen habe, das ist sehr groß gewesen. Das Gebäude, das ich gesehen habe, das ist sehr groß gewesen.
Or we can also just pick random points in those vector spaces. For example, here we set the dialect embedding to the Zurich dialect, and then we just take a random spot in the speaker space, and then we get a new Zurich voice. Here as a reference, the original one.
Das Auto hat komische Sachen gemacht. Das Auto hat komische Sachen gemacht.
So as you can hear, it's a different voice. Here for the other dialects.
Hört auf, mich gerne zu kritisieren.
Hat taube Ohren vergeblich predigt.
Maybe you can hear that the quality is a little bit lower for those random new voices. That's just one of the side effects you get from not taking the original voice and creating a new one. All right, so next up, let's talk about our Swiss voice assistant, which is a research prototype that we just developed as a proof of concept of how useful our dataset actually can be. We work together with Recap. Recap is focused on speech recognition in Swiss German. I think we even have David, the CEO of Recap, in the call. So what we did is we took the speech-to-text technology from Recap for the speech-to-text part of our voice assistant. Then we built some very simple skills based on the Mycroft AI framework, which is it's an open source library, let's say, for voice assistants. And then we took our text-to-speech part from Entity and built a small voice assistant with it. So it's only a proof of concept, just a research prototype. And we support a couple of small skills. So, for example, we can switch the dialect. We can give a weather forecast. We can read the headlines of the news. And we can tell the time or tell a joke. So, due to that, I just want to show you a quick little video where I'm talking to the voice assistant, and she answers to my questions.
Hey Mycroft, welcher Dialekt wird verwendet?
spreche Zürichdeutsch.
Hey Minecraft. Wie spät ist es?
Jetzt ist es 20 ab 3.
Hey Minecraft. Erzähl doch mal einen Witz.
Wie unterscheidet man deutsches Bier von einem holländischen 11 Meter? Das deutsche Bier geht immer rein.
Hey Minecraft. Wechsle Dialekt zu Bündnerdeutsch.
Im Moment, ich wechsle den Dialekt. Dialekt wechseln zu Bündnerdeutsch.
Hey Minecraft. Wie wird's Wetter am Freitag?
Die Prognose am Freitag hat einen Hochpunkt von 2 und einen Tiefpunkt von 2.
Hey Minecraft. Brauche ich morgen einen Regenschirm?
Es wird kein Regenmann vorhergesagt.
Hey Minecraft. Wie wird's Wetter morgen in Kambodscha?
Morgen wird es leicht regnen mit maximal 28 und minimal 20 Grad in Kambodscha.
Hey Minecraft. Wechsle Dialekt zu Berndeutsch.
Einen Moment, ich wechsle den Dialekt. Dialekt gewechselt zu Berndeutsch.
Hey Minecraft. Wie ist das Wetter in Bern?
Es ist im Moment bedeckt bei 11 Grad. Laut der Vorhersage liegt die Höchsttemperatur bei 3 und die Tiefsttemperatur bei 3.
Hey Minecraft. Wie spät ist es?
Aktuell ist es 20 ab 3.
Hey Minecraft. Was sind die aktuellen Schlagzeilen?
Das sind die neuesten Schlagzeilen von SRF. Ist die Zeit vom Ständemeer abgelaufene Frau Beiler. Das sind die 5 umstrittensten Vorlagen der Wintersession. Der Corona-Pandemie ist das deutsche Wort vom Jahr 2020.
All right. So, whoops, now you probably heard enough about the weather. So at least I want to say a big thank you to all the team members and all the people that worked on this project and helped the project. Yes, and that's my talk. So I guess I'm open now for questions.
Thank you very much, Julien, for this nice Swiss dialect samples. I think you can just turn on your microphone and ask a question or comment on what you just saw on other initiatives, or you write to the chat if you feel uncomfortable opening up the microphone.
There's already a question in the chat. So is there a link to the web API? No, our web API is not public. We don't have the server capacity for that. But you can write us an email to the MTC group, and then I'm pretty sure that we can give you some access to our API to do some tests if you want.
Any comments from the audience?
Yes, first, congrats. I'm quite impressed from what we've seen here. I didn't think that it would be possible so near in the time. You mentioned, Julien, that you used the Tachytron architecture, and I wondered, could you easily just use the Tachytron architecture, or is there a kind of a translation API in between? Because you use high language German text and just the audio. So, and Tacotron is character-based, so I wonder how it actually managed to translate this.
Yes, good question. So for the just plain speech synthesis, we actually use Swiss German text as an input for Tacotron, and then we synthesize the speech. But for example, for the voice assistant, we actually have to include a translation step from High German to Swiss German, because all those skills for the voice assistant, they basically work in High German, because there we have a lot of resources which we can just use. And then we get from those skills, we get a High German answer back. And then, yes, then we first have to do this translation step from High German to Swiss German, and then we can use our speech synthesis models. And because the Swiss dial dataset has High German, Swiss German transcripts and also the High German translation, it's easy to also make a small machine translation system with our dataset.
Oh wow! And that works so pretty. That's quite cool. I tried a similar with Akimop in my own studies, but wasn't brave enough to try it with two Swiss German part. So
yeah, but
pretty
as you
cool.
can hear, for example, in the video that I showed you, there are still quite a couple of mistakes that also come from the machine translation.
Perhaps just one more question. So the Swiss style dataset, was it big enough? I think 30 hours is a good starting point, but perhaps it's very low on some dialects, like 2 hours. That's not a lot.
Yes, so for our speech synthesis training, we always first pre-trained on High German, which helps a lot. Yes, and in this case, around 3 hours that we have, at least for each dialect, is enough to have a decent speech synthesis model. But I guess for a really good speech synthesis model, you will need 10 hours plus per dialect.
Because what is actually your WaveNet derivative? There are many different WaveNets. First, the WaveNet first came out, and there was a second one parallel, and then now 5 years later we have many different ones. So the first question would be which model. But I thought when I first seen this approach, don't you train it on all those dialect voices? So you're learning not just on one speaker, you learn it on all those, I don't know how many speakers you have, 50 or more. And then you create an identity vector and do a global conditioning of this WaveNet derivative and say, hey, I want to have this speaker. And then you can also interpolate between random speakers. So when I've seen the presentation, I thought you're training it on all those voices in the dialect, but apparently you're not doing this.
Okay, so first to the models. Yes, we use the plain WaveNet, the original WaveNet, for the high quality samples. For the voice assistant on our API, we needed a faster model because WaveNet is quite slow, so we used WaveGlow from NVIDIA. Then to the training, so we trained single speaker models, so only on one of the dialects for each dialect. And we also trained multi-speaker models. So in those interpolations and random new voice results, those are actually from our multi-speaker, multi-dialect model, where we exactly did those learned vector embeddings for the different speakers and different dialects. But the thing is that we didn't saw a huge, like a big benefit from training a multi-speaker model compared to a single speaker model with respect to the output quality.
I thought it's the better quality for the multi-speaker. There was a nice Amazon paper 2018 where they told it's better to let a model learn from many different speakers because it's more filling the acoustic space instead of and having less data per speaker in compared to one speaker alone, a single model with more data. This was their observation, but they're not so easy to validate all this.
Yeah.
And yeah, WaveNet first, this is really slow, and there are now many new derivatives which are helping out. But then what about prosody? Because prosody, if you do such a thing, Tagatron is actually giving you the MFCC's conditioning then per spectral frame, the WaveNet vocoder. And then you have problems with the prosody. So you would actually also need on top of each dialect, I guess, also has a prosody aspect. And there it's a bit problematic to properly model the prosody. Do you have any observations on that, please?
So for us, it worked quite nicely with just Tagatron and WaveNet. So that's basically the quality that we get that I showed to you in the presentation.
Yeah, since 2 years, quite some works around how to model prosody in such WaveNet derivative vocoders or in general in MultiSpeaker TTS. But yeah, fair enough. Thanks. Great work.
Thanks.
Thank you very much for these informed questions. Time is almost over, I would say. Half a minute. I'm curious how you do the code switching thing. Can you give a 20-second answer to that?
So we use a super simple approach where you basically, so we have a character level input and we just have different encodings for each character in the two languages. So the character A in Swiss German has a different encoding than the character A in English. And that's how we tell the model that it's a English and not a Swiss German word. And then we pre-train it on a multilingual dataset.
Okay, thank you very much.